Okay, again, why deep learning? Okay, that is that figure shows why deep learning, why we so interested in deep learning is because as you can see that the conventional approach, the conventional machine learning, okay, we just focus on supervised learning. Okay, the conventional supervised learning, when you increase more and more training data, as you can see that the performance doesn't matter, the performance is represented by loss or that represented by accuracy. I think this one is just assume this is accuracy. As you can see, the accuracy is not improved. It is not improved at all. If you increasing the data, that means it's already absolute. Okay, the approach is already absolute because even you have a huge number of data, training data, but the improvement is not so drastic. Okay, and we can consider the improvement is almost flat even you are supplying more and more data, because the function again, when we imagine the ANN, the multi-layer perceptron with one single hidden layer, okay, if you supply more and more data, the W is not fine. The W that we have in this architecture is not so big. Okay, because of that, okay, you can only find the optimum value, which is even you supply more and more data, it cannot be changed. You cannot change the minimum cost function there, because the cost function already achieve the minimum value as possible that ANN can achieve. Okay, with that small number of W. So that's why they go for deep learning. Like I said before, deep learning, which is also referred as a deep neural network, when you added more and more hidden layer, then you will have more and more W. Once you have a more and more W, and your network architecture is also become more complicated, which is represent a complicated function, then if you supply more and more data, it will keep improving, because you have many W which still cannot find the best value to represent an optimum W which produce the minimum cost function value. Okay, again, this is the three field that make the deep learning or deep neural network so popular today. Okay, one is the image. This is also referred to what we call as a computer vision. Okay, I think for those who take image processing, I already mentioned to you what is differentiate between image processing and computer vision. Image processing is, if the input is image, the output is still image. So meaning that input image, the output image, that is image processing. But computer vision, input is image, the output is the interpretation of that image. So that is computer vision. So that's why computer vision is the big umbrella where the image processing is one of the module inside the computer vision. Meaning that during the conventional way, in the conventional way to develop a computer vision, where the input is image, the output is interpretation or labeling the image, you need to have a image processing module, which is for the purpose of removing any noise from the image. So that's why the input is image, the output is image as well, and then the output from the image processing will go into other module, and the end, the back end of the back end of that system, it should be the input will, the output should, the final output should be interpretation or label. So that is where the machine learning become one of the module in that things. Okay, maybe I can give you some idea by drawing at the whiteboard, otherwise you also get confused. In general, let's say the input is image, and then This is we can call it as a pre-processing. Okay, and then you go to, there's also one other module which is might be segmentation or image segmentation, and then we have here feature extraction, and then here we only have machine learning, or should be supervised learning. Okay, supervised learning, and then label image, label or interpretation of the image. Okay, for example, again, when we use this the similar example that we have given before. If the image is image of dog, then the output here will label as a dog, because dog, the text dog here interpret this image. If the image is cat, then the output is also will provide a text or the word cat there as an output. This big thing is called computer vision, because the input here, because the input is image, the output is interpretation. So this is computer vision, CV, computer vision. So this part is image processing. So for those who learn image processing, they learn this one. So that's why if you see the syllabus in image processing, we start with image enhancement, that image segmentation, morphological, and then the major thing is image enhancement there, image enhancement as well as image restoration. So that image segmentation and image restoration is to remove the noise from the image, because we want to produce a good image here. Before you do some segmentation where you differentiate between the pixel belong to object of interest and the pixel belong to the background, because you only interest with the data that belong to, that represent, or the pixel belong to the to meaningful information, which is the object of interest. So that's why we don't want to have a pixel of background to fit into this process. Okay, so that's why you learn image processing. But that's why to differentiate between image processing and computer vision. Image processing, the input is image, the output is also image here. Okay, the output here is still image. But computer vision, the input is image, the output is interpretation. So in order to extend image processing and make it become computer vision, then you need to have these two modules. One is feature extraction, another one is classification here, classification. Okay, and to apply to do classification, then you need to learn the machine learning, because machine learning is the module that can recognize the pattern, because the things that is then go through this module as the input is a pattern or feature. Okay, from the feature and from the pattern, then this machine learning can classify or interpret that pattern. So this is the conventional way to do that. Okay, but because of the introduce of deep learning, what happened is actually, again, if you discuss about the definition of deep learning or deep neural network, you don't have to you don't have to make it step by step module like this. Okay, because the deep neural network can accept a raw data of image. So meaning that the input is image, you just apply deep learning or deep neural network, then the output you can, the output provided by this deep neural network is the interpretation or label. So that is why by only using this deep learning module, it can be considered as a computer vision, because the input is image, the output is interpretation. So that's why this module replace all this module, and is it because the input is image, the output is interpretation, then is actually managed to replace this module and become as one of the technique under computer vision. Okay, so that I just can discuss detail more about computer vision. That is computer vision. Okay, so that is what happened. Things that you want to do with the data is that if the input is image, the output is, you want to label the image or you want to interpret this image. If this is what you want to do, this is called as computer vision. So that's why computer vision is one of the field that make one of the field that deep learning managed to tackle and outperform the conventional approach is computer vision, which is the input is image, the output is interpretation. Other than that, there are another two field that make the deep learning outperform the other conventional method inside that field, which is this one. The input is audio, the output is speech recognition. What is that? That is not okay. This is, again, don't confuse. I only discussed about this one before, which is computer vision. Okay, so that's why for those who doing research in image processing, normally they for sure also need to extend or further their study on computer vision, because they are something which is strongly connected. Okay, you cannot just learn image processing then you finish up until image processing, because now the application today, most of the image processing normally will also expert in computer vision, because they are related, they are connected together. This one is speech processing. Okay, speech recognition. I think this one, the one who expert in this one is in our school is Dr. Tan, because they always their works is their previous work more on speech recognition, and this one is text mining. Okay, for this one we still don't have expert in this one in our school. Maybe in School of Computing they have their expert in text mining, where the raw data is, they fit with the raw data of text. They try to do some web searching, or maybe I think the most popular right now for text mining is called semantic analysis. Sentiment analysis. Okay, sentiment analysis is about from the text, the deep learning be able to find out how much positive text, how much negative text. I think it's beneficial in marketing. Means that if you, let's say you want to sell something, and then you sell it in Facebook, and then there's a lot of people view your product and comment inside your Facebook, and of course if you want to read one by one, you cannot do that. So that's why they hired the deep learning expert to do sentiment analysis, so you can classify that comment into positive comment, negative comment, and neutral comment. So then you know how people hate about you, how people talk something good about you, and you know how good your product is it. Okay, that is where make a deep learning people can make money, because they can work in business company. Okay, but another application is, I think, in election. In election, people also use the sentiment analysis to know your voter, and then to know what to offer to your voter before the people can vote for you. So this is also being used in Malaysian election. Okay, but I not expert at that. I just know on the surface. So these are the three fields that have been or we can say that deep learning becomes so popular because of these three fields. Because once they introduce the deep learning, practically, where actually deep learning managed to outperform the conventional method on each and every field in these three category. Okay, because once they introduce the deep learning, they manage to outperform the conventional method in computer vision, as well as speech recognition, as well as text mining. Okay, so that's why it's become deep learning has become popular, because they try to tackle that, and after that, deep learning have been used with to in many fields. It's not just this computer vision and speech processing and text mining. It have been used in many signal processing application, as well as other image processing application as well. But this is the three field which make the deep learning so popular. So that's why if you some people talk about when people say that why I'm doing research in deep learning is because my field, my original field is in computer vision and image processing. So if I don't explore deep learning, then I will left behind like that, because deep learning now is conquering the computer vision. Okay, same goes to people who are expert in speech processing or text mining. If you don't learn the deep learning, then you will leave behind. You will left behind, because now deep learning is conquering the speech recognition as well as text mining. Okay, this is application in computer vision. Again, what is computer vision? This is the example that maybe you capture the picture by using your handphones, because your handphone. Why computer vision in implementation of deep learning is very popular in computer vision? Because computer vision is about interpreting the image. So of course nowadays you can you have, everyone have the mobile phone, and the mobile phone have the camera. So that's why, because of the camera, everyone can capture the image. So now image is easily accessible, and everyone can have image. So that's why deep learning is become popular in computer vision, because now everyone have the image. So why not you implement something? You can develop something, you can develop some technology which is you can get benefit from it, because everyone in this world is a user of the camera. So that's why you must not avoid from developing something which is using the image itself. Okay, as for this example, computer vision try to identify, can you you ask the computer, can you identify the coffee mug inside this picture? Of course, if by using your interpretation as human, it's easy for you. Where is the coffee mug? It should be this one. But for computer to recognize this mug, it's very challenging, because they need to differentiate between the pixel belong to the background and the pixel belong to object of interest, which is this mark. Okay, this is some of the example where the computer vision fail to do that. Try to search which one. First they test this one, and then they say that it might be this one, it might this one, or it might be this one. Of course, it's very challenging there to identify which one is a coffee mug. Okay, so why is computer vision is so hard? Again, when I just crop that part, okay, and see what is actually the camera see, or what is actually the computer see, is a huge number of a set of number which is represent the pixels there. Okay, you see the pixel in color, but the what is computer see is a huge number that represent that color. So that's why it is very difficult for computer to interpret which pixel or which area belong to a coffee mug, as compared to human, because the human just see the colors there, but this color is actually represented by this number, but this number to interpret is a very huge. So that's why computer vision is something which is very challenging and very hard. Okay, so of course you need to pass all this value into learning algorithm, which is our machine learning, or in other words, this is machine learning. And this is the conventional method that I explained before. Before the deep learning, this is what we call as computer vision. Of course, this block in this block this should be an image processing block here as well, because this one in this slide they want to simplify the slide, so that's why they remove the block which is belong to pre-processing as well as segmentation there. But this is the conventional approach in computer vision before they introduce the deep learning, meaning that you cannot simply pass this value into learning algorithm. Again, why is that cannot be done? That is related to this slide. Yep, this one. Okay, because the conventional learning algorithms, even because the image itself, you can see that image. Okay, the only one small patch here is represented by this big number. Imagine this, the whole pictures here. You will have a huge number of data. So by feed all this data into learning algorithm, it does not improve, because that situation you actually have a lot of data, but because of the limitation of the existing learning algorithm, the accuracy is not improved. That is one of the reason. The second reason, the data is not so big. Only the dimensionality of the one sample data is very huge. So that, but the number of sample is less. That is also make the overfitting happen. Okay, so that's why you cannot simply pass the raw data into a conventional machine learning model or learning algorithm at that time. Okay, so that's why in order to solve that, the computer vision community try to formulate what is called as a feature representation, or in some paper call it as a feature extraction. Okay, because some also call it as a feature extraction. So normally the feature extraction, the purpose of feature extraction is to find the formula, the formula inside this one. Okay, will reduce the dimensionality of your data. Means that, let's say this one is 100 times 100, so you will have, let's say 10,000 features, 10,000 data go into this feature extraction module. So it will end up, let's say, like 10 features, or 10 dimensionality, 10 dimension feature from 10,000 dimension feature. So once you have 10 feature, then you can just simply model your learning algorithm by using let's say you choose an ANN, then you will have only the 10 input here. Okay, the 10 input, then you just design your neural network to classify your data here. Okay, you can do like that. Okay, but if you directly, without this part, let's say you want to directly apply the raw data, then you need the input as too many input, which is 10,000 input. And let's say you have only how many sample here? This is only one sample. Let's say you have 1,000 sample. So 1,000 sample, but each sample have 10,000 input. Of course, it's not balanced, it's not equivalent. So that will make your training process produce the overfitting phenomena. Okay, because of a huge number of dimensionality and small input samples. So that's why at that time, by implementing in this condition cannot be done. It cannot be done because of that. So that's why before you can classify the pattern by using this learning algorithm, then you need to have one modules there, which is called feature representation or feature extraction, which will reduce the data. Actually, the purpose of feature extraction is to find the meaningful pattern from this huge number of pattern. Okay, so then you will have you can use your learning algorithm to classify this image. So this is where actually also make your this thing happen. Okay, in conventional machine learning, because you have a huge number of data. Let's say you have a huge number of data, but your dimensionality input at your classifier is only 10 dimension or 10 features as an input at this learning algorithm. So even if you have a very big data or rich number of data, the performance is absolute there, because this learning algorithm is only depend on only 10 information or 10 dimension 10 dimensional dimension of features. So means that your learning algorithm have a limited number of meaningful information fit into this module, this learning algorithm. So that's why this trend happen. Okay, that is one of the reason why this trend is happen even you have big amount of data. So that's why when you have a lot amount of data and with a great or high speed computer technology, this is a two factor make this deep learning become more and more popular today. Because once you have a big amount of data and the big architecture of deep neural network can be implemented in your high speed computer as well, so then you don't have to think about designing in this way. Instead of you can directly design in this way, because now doesn't matter your input is 10,000 dimension and your input network is 10,000 dimension, because you already can extend this neuron here with a huge number of neuron. Then because of your the computer technology they can implement it, the high speed computer can implement it, you can have huge number of neuron here. Then the deep learning can be implemented today because of that. Okay, because of once you once again I repeat, one is because of the computer technology, because you have currently we have a high speed computer that make you can design a huge number of network here, okay, or in other words is a deep neural network here, where it can tackle the high dimension input here. So because of it can tackle high dimension of input here, then you don't have to design this module anymore. You can directly transfer this raw data of image into this network. So that's why it become like this. And the third things is that because of you have a huge number of data. Of course, if you don't have huge number of data, let's say you want to design something like this, means that you skip this process. Okay, you skip this process, you pass this one to this network, and you already design this network with multiple hidden layer that become a deep neural network. But if you don't have a big sample of data, it's also you also cannot train this W, because the W is very huge. So in order to achieve a converge or to achieve the W or the optimum W which reduce the minimum value of cost function there, you need to have a big data, because now because otherwise this overfitting is still happen. Because if let's say you still have 1000 data, but 1000 sample, each sample have 10,000 dimensionality, so it's not good. That will also make your system suffer with overfitting. So that's why when you have a very a big amount of data, let's say 1 million or maybe 1000 million and so on, which is more than the dimension of the dimension of a sample of data, then you already design your network as a deep neural network, and then you can accept 10,000 data. That's why you don't have this. That's why you don't have to design this thing anymore, because of this 10,000 of input, then you have a lot of information. So that is one of the factor make this deep learning, when you have a big number of data or number of sample, it will keep improving and improving. Okay, that is why this is one of the reason. Okay, but the conventional method, because of why they absolute at a certain value in term of performance, is because the reason is because of feature extraction, because feature extraction will only select the meaningful information, or the important pattern that can make this learning algorithm interpret this image. So because there's a limited number of input here, that's why it doesn't matter you supply a small number of sample or big number of sample training data, the performance is not improved at all. But if you extend your learning algorithm into deep neural network, where the input is more than 10 dimension, or more than 10 features there, or 10 attribute, then you can skip this module, feature extraction or feature representation. You can directly pass the pixel to this as an input of this one, which is become something like this. But of course, to improve the performance of this one, you need to have a very big data. If you still using 1000 sample training data, it's overfitting will happen. So that's why in this graph here showing that if you what is the motivation behind the deep learning, is because currently we have a lot amount of sample, or a lot amount of data, and it find out that if you supply more and more data, the deep neural network here keep improving in terms of the performance or in terms of accuracy because of that. Okay, but at this one, why it's not improved? Because of the input is the dimension of features here is limited. It's only 10 features, like in these examples. Okay, it's only 10 features. So that's why if you supply more and more data, it does not improve at all. But for this one, again, for this one, even you have, it will keep improve there. You cannot, the condition that you must supply it with more and more samples. If you still have, let's say 1000 sample, then overfitting will happen. Why? Again, the explanation there is there, is here. Okay, you have 1000 sample, but one sample have 10,000 dimension or 10,000 input, overfitting will happen. Okay, there is some detailed explanations there.